Welcome to The Explainer. Have you ever wondered how your phone just knows where all the faces are in a photo? Or how a self-driving car can, actually see the road? Well, today, we're diving into the fascinating world of artificial intelligence that has learned how to see.
The answer is a really powerful form of AI that's learning to interpret our world visually. And the wild part is, you're already using it every single day, probably without even thinking about it.
So, this technology has a name. It's called computer vision, and it is quietly but massively revolutionizing entire industries by giving machines what is basically the power of sight.
And this right here is the absolute key. It's not just about a machine seeing a bunch of pixels, it's about it understanding what those pixels represent. That it's not just a collection of dots, it's a car, or a person, or a cat.
Okay, so how does this actually work, right? How do we go from a lines of code to an AI that can tell the difference between a dog and a cat? Let's get into how these machines actually learn.
So, this slide shows the huge shift that made all this possible. The old way, on the left, was a nightmare. Humans had to sit and write endless rules. A cat has pointy ears, it has whiskers, it has this kind of tail. It was slow and just didn't work very well. The new way, on the right, is a total game changer. Instead of feeding it rules, we just feed it experience, thousands and thousands of pictures of cats, and we let it figure out the patterns for itself.
And that's really the magic here. We've swapped out that tedious manual rule writing for a massive visual library. It's like we're letting the computer learn from experience, not from a textbook.
And this really gets to the core of machine learning. The more data it sees, the smarter it gets. The goal isn't for it to just memorize the pictures it's seen. It's for it to learn the idea of a cat, so it can spot one in a brand new photo it's never seen before.
Now, the brain behind all this deep learning has a specific name. It's a special kind of AI called a convolutional neural network, or CNN for short. You can just think of it as the engine that's built specifically for understanding images.
And the way it works is so cool. It's actually a lot like how our own brains work. The first layer of the network might just see simple things, like edges and colors. The next layer takes those edges and builds them into basic shapes, like circles or squares. Another layer combines those shapes into an eye or a nose. And after going through all these layers, it finally puts it all together and says, yep, that's a cat.
So now that we have a sense of how it works, let's get to the really exciting part. What can we do with it? Let's start with a field where this technology is literally saving lives every day: healthcare. I mean, just imagine you're a radiologist at the end of a very long shift. This AI can act like a tireless second set of eyes, scanning that same X-ray and highlighting anything that a tired human might have missed. It's an incredible safety net. And we're not just talking about looking at X-rays. It's being used all over the place, from analyzing cells on a microscope slide to spot cancer, to actually guiding a robot's arms during surgery. It's becoming part of the whole healthcare system.
So, what does this all mean? Well, it means we're getting diagnoses that are faster, cheaper, and sometimes even more accurate than what we had before. This is a huge deal for making good healthcare more accessible to everyone. But, and this is a really big but, it comes with huge responsibilities. A mistake here isn't like a typo on an email. A false negative could mean a missed diagnosis. We have to be incredibly careful with patient data and, crucially, make sure these systems work fairly and accurately for every single person.
So, we go from saving lives to watching them, because the exact same technology that can be trained to find a tumor in a scan can also be trained to find a face in a crowd. And that brings us to a much more controversial area: surveillance.
You have to understand, modern cameras aren't just passively recording anymore. They're actively analyzing what they see in real time. They're looking for everything from an unattended bag in an airport to managing the flow of traffic in a smart city.
And this right here is the fundamental tension, isn't it? The potential to make our world safer and run more smoothly is enormous, but it forces all of us to ask a really tough question. How much of our privacy are we willing to trade away for that safety?
One of the biggest red flags here is bias. We've seen that some facial recognition systems are less accurate for women and people of color. Now, that's not just a technical glitch. That has huge real-world consequences and can lead to really unfair outcomes. So you can see, it's really two sides of the same coin. The future of computer vision isn't just about building more powerful tech. It's about figuring out how to build it responsibly, with fairness and ethics baked in from the very start.
Okay, so we've talked about the amazing potential and some of the serious pitfalls. But what if I told you that you could build one of these AI models yourself, like right now, with zero coding?
Well, there's this incredible free tool from Google called Teachable Machine that lets you do exactly that. It totally demystifies this whole process and lets you see firsthand how an AI actually learns. It really makes all these ideas come to life.
And it's honestly as simple as 1, 2, 3. You just gather some pictures, click a button to train the model, and then you can test it out right away in your browser. It's that easy.
This is just so cool because it shows how this powerful technology is becoming accessible to everybody. You go from just hearing about it to actually building it. You could train a model in like 30 seconds to know the difference between your coffee mug and your water bottle.
So here we are. We've done it. We've taught AI how to see. And now that this power is in the hands of more and more people, the real question, the one that we all have to answer together, is deciding what exactly we should teach it to look for.